Armatures are the foundation of what animators use to animate their characters. They are also known as rigs or skeletons, and like skeletons, armature objects are made up of bones. Bones are the individually moving parts of a skeleton or armature that dictate where and how the skeleton can move, just like real bones in a real skeleton. With armature objects, we can create and edit bones and then transform these bones to animate them. Let's see how that works. First things first, you can add armatures to your scene by going to the Add menu and selecting Armature. This will add an armature with a single bone. The cube is a bit in the way, so let's hide it for now in our outliner. For hotkey users, you can also select the cube and press H, as in hide. With this armature object, we have two modes other than object mode that we can go into. We can edit the bones by going into edit mode, and we can pose bones in pose mode. Posing is where you'll be doing most of your bone animation as well. You can enter both of these modes by going to the top left-hand corner, but for hotkey users, you can also press Tab to toggle in and out of edit mode, and Control Tab to toggle in and out of pose mode. But right now, we only have one bone, so let's go into edit mode and change that. Once we're in edit mode, the bones that make up our armature object can now be edited. This is very similar to how we edit vertices, edges, and faces for a mesh in edit mode. Now, a bone is made up of three parts: the head, the body, and the tail. The head is the base of the bone, and also its pivot point. The tail is the narrower end of the bone, and the body is the main body. You can edit bones in three ways. You can select and move both the head and tail of the bone individually, or you can select the middle of the bone and move, rotate, or scale the bone as a whole. Now that we know that, I'm going to very quickly try to rig the spine of this character. You can download this character in the description down below. Let's go ahead and add an armature object like we did before, and then go into edit mode and drag the tail of our bone all the way up to the top of his head. If we want to add more bones, we can also do that in a number of ways. Using the Add menu at the top, we'll add a new single bone, not parented to any existing bones, which you can then move wherever you want. But if we want to attach it to our existing bone, we'll have to parent one to the other. Parenting plays a huge role in armatures and bone relationships, as it drives the foundation of how a rig moves. When we select our new bone and parent it to our existing bone in edit mode, you'll find a few different options: Connected and Keep Offset. Connected will automatically move the entire child bone to the location of the tail of the parent bone. This is because connected bones must share a head and a tail. This is great for bone chains like spines, where the joints are perfectly shared. However, Keep Offset will ignore this requirement and act similarly to how object parenting works, where transformation is inherited regardless of the child's relative position to the parent. This is great for ears or eyes, where the pivot of the deformation doesn't relate to the parent's tail position. Another way to create bones is to simply select a bone and subdivide it. This is done by using the right-click context menu and selecting Subdivide. This will turn your selection into a chain of connected bones. As usual, you will have an operator panel appear in the bottom left that you can expand and adjust the number of cuts. But you can also extrude new bones from existing bones by using the Extrude tool. This can be found in the left-hand side Quick Tools menu in the same way the Extrude tool is used on meshes. For hotkey users, you can press E as an extrude as well in the same way. You can extrude bones from the head or the tail of a bone. Make sure you have one or the other selected and use the Extrude tool. You can also extrude multiple bones depending on how many heads or tails you have selected. Bones created from extrusion are connected by default. You can disconnect these bones by unparenting them, which can be done through the right-click context menu, going to Parent, and selecting Clear. For hotkey users, you can also press Alt-P. However, here we'll see two options pop up. Disconnect will disconnect the bones, allowing you to move them away from the tail without affecting the bone it was connected to. But it will keep the bone parented to the other bone with an offset. Does this sound familiar? Well, that's because this is the same state as the Keep Offset option when parenting bones. On the other hand, selecting Clear Parent will disconnect and sever the parent-child relationship completely. Another tool you can use from the toolbar is the Roll tool. Bone roll dictates simply how a bone is rotated along its vertical axis. This is typically its local y-axis. Why would you want to use the Roll tool? Well, assuming you have something simple like an elbow to deform, and you know elbows only bend in one direction, you would want that direction to be along an axis of rotation, X, Y, or Z. To view the axes of your bones, simply go to the Armature Data tab of your Properties editor, denoted by this green stick figure icon. Then go to Viewport Display and check Axis. Suddenly, all of your bone's axes will become visible. You can use the Roll tool by simply left-click dragging anywhere in the viewport to rotate the axes of the bone to align with how you want it to transform later. You can also edit the roll in the Bone tab of the Properties editor, denoted by this green bone icon. Simply left-click drag the roll value or left-click tap and enter a number manually. And the last bone editing tool you can select is the Bone Size tool. This is not the same as scaling the bone, and you'll notice that if you left-click drag, it doesn't do anything. That's because these changes are only visible with a different bone display. Simply go back into the Armature tab of the Properties editor. Under Viewport Display, we can open this drop-down to select different kinds of bone displays. For the Bone Size tool to reflect any changes, you'll want to choose either the B-bones or the envelopes display. Now, when we left-click drag this tool, you can see the width of our bone changing. You can read more about what each of these bone types do in the official documentation, which you can find in the description down below. But most of the time, you can choose one based on preference. I typically keep it on octahedral, but some people prefer stick, for example, to simplify the visuals. Now, let's go ahead and talk about how to use these bones for animation. In order to do that, we need to understand how pose mode works. Let's go into pose mode by either selecting it from the drop-down or pressing Ctrl Tab. This will then turn all of our selected bones blue. Transforming a bone here will actually record location, rotation, and scale in the individual bone data. With this, we can finally add keyframes for these bones in pose mode by right-clicking and going to Insert Keyframe, Lock Rod Scale. This lets us animate. But you may have noticed that when we move our bones, our character still doesn't move. So how do we make sure our bones actually move our character? In Object Mode, we can simply select the mesh, Shift-select the armature object, and open the parenting menu either through the right-click context menu or Ctrl-P. You then might notice the option for Armature Deform, with 3 sub-options below that. The most commonly used one is with automatic weights, as it gives us a great starting point, but feel free to read up on the other 2 options in the official documentation. Once we've selected this, you'll notice that when you transform individual bones, each bone has been assigned a group of vertices that will deform with it. This is being handled by vertex groups, also known as weights, which have been automatically generated by Blender based on the placement of the bones relative to the mesh. We'll be going over vertex groups in a separate video. If you select your mesh and go into its Modifiers tab, denoted by the wrench icon, you'll notice that it now has a new modifier as well, the Armature modifier. This is how Blender uses armature objects to deform meshes based on the transformation of individual bones. Now, obviously this rig is incomplete, and if you want to learn how to rig the entire character, you can head over to our character rigging video. But I hope this gave you a good idea of how armature objects work and how to edit them.